I hope I'm clearly audible, right? So today we are going to discuss homework of 6.3, 6.4 and 6.5. I hope all of you have solved the problems, right? Good morning, Sneha. Good morning, Aryan. Good morning, Tulika. Good morning, Jitendra. Voice is not low, okay. I'm hearing my voice and it is quite loud and clear. Okay. Everyone, can you hear me loud and clear? Because I can hear myself loud and clear. There's no issues. Yeah. Okay, everyone. Right? So we will start today's class. So I hope all of you have solved the homework of 6.3, 6.4 and 6.5. Okay, so we will start with 6.3. Okay, so here are the problems of 6.3 homework. Just let me know what is your doubt. Okay, so tell me, anyone have any doubt between 1 to 5? Tell me everyone, 1 to 5. Any doubt between 1 to 5? Okay, question number 5. Before question number 5? Anyone? Before question number 5? Okay, 5 only. Okay, we will see question number 5. So before question number 5, no one have any doubt? I guess. Fourth one, okay. Fourth. So let's see first question number 4, then 5. Okay, now let's see question number 4 first. Now when you see question number 4, we have a reaction, right? The reaction is, what is the reaction? The reaction is this. 2NH3 plus 4H2 gives 2NO2 plus 7H2. Delta H is given. Delta H of the reaction is given. Now, you are asked to find how much energy would be released if 50 gram of water were reacted to stoichiometric amount, right? So see, this is your total delta H. Okay, total delta H. So I can say that when 4 mole of H2O, 4 mole of H2O is reacting, the delta H is this. Right, everyone? Everyone is getting? When 4 mole of water is being used, delta H is this. For 1 mole of water, tell me, for 1 mole of water, it would be how much? It would be how much? Shreya, tell me. For 1 mole of water, it would be minus 142.5 by 4. Yes, everyone? Right? Now, it is given that we have 50 gram of water. So I know that 50 gram of water, right, divided by 18, because molar mass of water is 18. So this is the number of mole of water which is used, right? So I can say that the amount released will be number of moles of water into energy produced per mole of water, right? So this would be your answer. Okay, everyone, got this? Shreya, you got this? You can solve this, you will get the answer. Okay? Okay, everyone. Now let's see question number 5. Now see, in question number 5, what is given? First of all, you have to identify the type of reaction. That's what I said, right? In case of thermodynamics, we have to identify the process. While in case of thermochemistry, you have to identify the type of reaction. Okay, so if you see here, what we have. First reaction is dissociation reaction where half Cl2 means Cl is broken down into Cl2 is broken down into individual atom. Then it is electron gain enthalpy. Then you have hydration. Okay. So this is your 3-step. Now, what will be the energy evolved in the conversion of half Cl2 aqueous to Cl minus aqueous, right? To net energy is being asked. You have to use what? Hess law. Right, everyone? Can you use Hess law? Tell me. Can you use Hess law? Right? So since it is half mole, you have to add this. It is half into dissociation energy, which is 240 plus, right? Okay. Now this. Now since it is 1 mole only, Cl is 1 mole only, so minus 349 right? Because everything is a kilojoule. Okay, everyone? Now, plus, and again, since it is negative, it will be minus how much? Tell me, everyone. 381. So if you add them, you will get the answer, right? So it was a basic problem, everyone. It was a very easy basic problem of Hess law. Yes or no? Got it, everyone? Right? Okay. Okay, I guess everyone got this. Now, question number 6 and 7. Anyone have any doubt? Question number 6 and 7. Anyone have any doubt? 6, 7, and 8. 6, 7, and 8. If you have any doubt, please ask. Okay. Mansi, Anjali, Pritam, have you solved, Pritam? Question number 6, 7, 8. No one have any doubt? 7 is quite easy, I guess. 7 is a theory. Okay, even 6 is theory. Right, everyone? 6, you just have to calculate delta n. Right? Or you just have, no, not delta n, sorry. You just have to see delta H is negative. You don't have to do anything. Delta H negative, what does that mean? That means that the enthalpy of product is less than enthalpy of reactant. As simple as that. Right? So 6, 7, 8. 8 also, no doubt. 8. I hope all of you remember we have done a problem related to question number 8. Right? Okay, so you have to use delta H for 8. You have to use delta H is equal to delta U plus delta NGRT. Right, everyone? Delta NGRT. Okay. Okay. Okay, everyone. So question number 8 done. So let's see. 9 to 14. 9 to 14. 10, 11. Okay. 9. No one have doubt in question number 9, everyone? Okay. So 9, 10, 11, 13. So we have doubt in question number 9, 10, 11, 13. Okay, everyone. So we'll start with question number 9. Wait, I'll just shift this in OneNote. Okay, so I'll start with question number 9. Okay, so can you see question number 9, everyone? You can see question number 9, right? Okay, let's see what is given, what is being asked over here. So I know that we have a reaction, right? The first thing is identify your reaction. So it is clearly visible because it's already given. You don't have to form the reaction over here. So the reaction is what? It is H2O2 is dissociating into H2O plus half O2. And enthalpy change is given. The enthalpy of formation of H2O2 is this. It's quite easy problem, right? It is Hess law. I hope all of you remember this, right? Enthalpy of formation of H2O2 is given. So we know that delta H of a reaction, delta H of a reaction is equal to summation of delta H formation of product, right? Minus summation of delta H formation of reactant. Yes or no? Tell me, yes or no? Right, everyone? Okay. Okay. Now delta H of reaction is already given, which is minus 98.3. It is already given. Now product, in product we have H2O as well as H2O. half O2, sorry. But since O2 is in elementary form, O2 is your elementary form, right? So it will be 0. So you have just delta H of H2O. So I'll write delta H formation of H2O minus. Now this is your delta H formation of H2O2. Delta H formation of H2O2. Got it, everyone? Right? So delta H formation of H2O would be what? It would be minus 98.3 plus delta H formation of H2O2, right? Which is 98.3 plus what is given? Minus 187.4. Yes or no, everyone? Tell me. Yes or no? Easy. It's a basic application of Hess law. So the answer would be, just add them, you will get minus 285.7. Sorry, 285.7. My bad. Kilojoule. Got it, everyone? Question 9 clear? I hope question 9 would be clear. Okay, so let's see question number 10. So just go through question number 10. Now, question number 10 is also an application of Hess law, right, everyone? Question number 10 is also an application of Hess law. Let's see. Okay, everyone, just go through question number 10 first before we start solving. See question number 10 first. Okay, so I guess all of you have gone through question number 10. Let's see. Now in this problem, right, just see this problem. In this problem, enthalpy of combustion, right? Okay, enthalpy of combustion of SSO2 H2O are given, right? So what we have to do first is write down the reaction, right? So S plus O2 gives SO2. Write down the reaction. That's your first reaction. And delta H is already given. What is delta H? Delta H is given, which is equal to minus 298.2. Okay, now second reaction, right? Second reaction is again SO2. Okay, enthalpy of combustion of SO2. So we know that SO2 plus O2 gives what? SO2 will convert into SO3. SO3. So it would be half, right? It's fine if you don't balance, don't worry about that. So we have delta H is minus 98.7. Okay? And same with H2. For H2, it would be H2 plus combustion means just reacting with oxygen, O2. You know what will be formed, right? We will have H2O. And this will again be half O2. Right? Now, this delta H is also given, which is minus 287.3. Okay. Now, what you have to find? You have to find the enthalpy of this reaction. Okay. Now, enthalpy of this reaction is given. So, SO3 plus H2O gives H2SO4. Right. Now, this is reaction A, reaction B, reaction C, reaction D. Okay. And this delta is also given. Right? Now what we have to do, we have to identify the enthalpy of formation of H2SO4. Okay, enthalpy of formation of H2SO4. What do you think? This example of, tell me, this is example of Hess law, same Hess law, application of Hess law. So what will be the reaction? What will be the reaction for the formation of H2SO4? It would be simple. It would be H2 plus S plus O2. As simple as that. Because when you talk about formation, enthalpy of formation, The compound is being formed from its elemental states. Okay, so it would be H2SO4. Now let's balance this. We have 2O2, 1S, 1H2. So this is a balanced reaction. You have to find delta H for this reaction. Okay, now can you find, right, reactions by adding or subtracting these four reactions and convert into this fifth reaction? Tell me, can you do that? Try, just think about this. In reactant, you have H2, H2, and S. So A and B are your reactant. So A plus B, A plus B. O2 is also reactant, but O2 is already present here, right? Now, SO2 and SO3 is not your reactant. It is not here, right? It's not here. H2O is also not here, right? So minus B minus D. Okay? Now, let's do this. Let's do this until see what will happen. So I'm just adding A and B. I'm getting H2 and S. So it will be S plus O2 plus SO H2. H2 plus half O2. I'm adding A and B. Reactant side. Okay, this is your reactant side. Minus B minus SO2 minus half O2 minus SO3 minus H2O. Right? Gives. This was just your reactant side. Let's see the product side. Everyone is getting this right, everyone? It's quite easy. So product side, what we had. So first reaction was SO2. So I'll just do the same thing. Okay, SO2 plus B. In B, what we have, sorry, in C. Sorry, my bad. I have written here B, right? It should be C. Okay, it should be C. Okay, everyone? My bad. Okay, okay, everyone. So it will be SO2 plus H2O. Minus what? Minus we will have SO3 and H2SO4. Wait everyone. Wait. There's some error, I guess. We have to find, we should have H2O in product side, right? Okay, and SO3 is already cancelled. So it will be plus D. It won't be minus D, it will be plus D. Okay, because SO3 is already cancelled, right? SO3 is already cancelled. Okay, because H2SO4 should be on product side. So plus. So let's add this first. So SO3 sorry, my bad. Since SO2 and SO3 is already formed, now you need not to subtract anything. You just need to add everything because SO2 is getting cancelled over here. SO3 and SO3 is getting cancelled over here. And H2 and H2 is getting cancelled over here. Sorry, my bad, right? Okay, you don't have to subtract anything, just have to add everything. Okay, A plus B plus C plus D. Because everything is getting cancelled, right? So just add everything over here. Plus H2O, okay, plus H2O. Right? So see, SO3 and SO3 will get cancelled, SO2 and SO2 will get cancelled, H2O and H2O will get cancelled, right? So you are left with S plus O2 plus half O2, which will be, right? And this half O2 will give 2 O2. So you are left with S plus H2 plus 2O2 gives H2SO4, right? So this is your required reaction anyways. So delta H would be sum of all these delta H. Right, everyone? Tell me. Right, everyone? Okay. So delta H would be delta H1 plus delta H2 plus delta H3 plus delta H4. Right? As simple as that. Okay? Okay, everyone. So this was your question number 10. And now to question number 10. So this was a basic problem of Hess law, right? So you might ask how to write the reaction of heat of formation. Just take the elementary or the elementary components of a compound, right, which is existing in natural state in the reactant side. For example, H2SO4, if I are talking about H2SO4, H2SO4 is made from hydrogen, sulfur and oxygen, right? So hydrogen, sulfur and oxygen, just take it at elementary state. Hydrogen is gas, I'm just not writing the phases over here. Hydrogen will be gas, sulfur will be solid, and O2 is definitely gas. Okay, everyone? Okay, so this was my question number 10. Now, question 11, anyone had doubt in question 11? I guess someone had doubt in question 11. Let's see question 11. Okay. Everyone go through question 11. So see what is given. Internal energy is given. Just write down what is given. Delta U is given. Delta U is given. What is delta U? It is 0.21 kilojoule. Okay. Calculate the enthalpy change when pressure of 1 bar, right? Given that the densities of solids are this and this, respectively. So we know that delta H is equal to delta U plus P delta V. Yes or no? Right? Pressure is given. Now you have to find volume. So delta V is equal to V2 minus V1. Just think like this, right? And density is given. Okay, so what's the meaning of density? Tell me. We know that PM is equal to DRT. Right? And PV is equal to nRT. And density is equal to mass by volume. So we have these three formulas. Just think what we have to use. So volume is equal to mass by density, right? Now you might be thinking, which of these three formulas we need to use, right? So obviously this is and this is not needed because mass is already given. Mass is already given, right? How? This is 1 mole of calcite, 1 mole of CaCO3. We know that 1 mole of CH3 will have molecular mass, which is 100. So V2 is already given. Mass is already 100, right? Mass cannot be something else. So V2 would be mass by density. What is density? First one density, right? 2.71. And V1 is 100 by 2.93. Got it, everyone? Tell me, got this? Right? So it's just calculation. I hope all of you can solve this. Okay, everyone? Sorry, it is opposite because it is converted from calcite to arsenite, right? So it would be opposite. So it would be V2 and this would be V1. Right? You can just V2 and this would be V1. But you got the concept, right? Okay. Okay, everyone. So question number 11 clear. Okay. So let's see question number 12. 12, I guess no one had doubt in question number 12. Question number 12, it was basic formula, right? Change energy is equal to delta Cp delta T. 12. Okay, Pranjal. 12, you have doubt in 12. Okay, everyone. See question number 12 here. So what is question number 12? Question number 12 says that specific heat, what is question number 12? Specific heat of iodine vapor and solids are this and this. So obviously it is converting from one phase to another phase, right? Heat of solution is given. What is its value at 250 degrees centigrade, right? So we know that, what is the reaction? Reaction is this. I2 solid is getting converted into I2 gas. Right, everyone? Okay. Now specific heat is given. So Cp of solid is equal to 0.031 and Cp of vapor is equal to 0.055. Okay, right? Now, what is delta Cp of a reaction? Delta Cp of reaction would be 0.031. Wait, okay, ulta. I have written ulta, I guess. Sorry, my bad. So this is your vapor and this is your solid. Sorry, my bad. I've written opposite. Okay. So 0.031 minus 0.055. Okay. So what you will get? You will get 0.024. Okay, everyone. Minus. Okay. So this is delta Cp. Now we know that if we have two different temperatures, so it is actually your two different conditions. So we know that delta H1 is equal to delta Cp T1 and delta H2 is equal to delta Cp T2. Yes or no? Tell me. Yes or no? Right, everyone? So delta H2 minus delta H1 is equal to delta Cp T2 minus T1. Okay, can you solve this now? Tell me, can you solve this now? Can you find delta H2 because delta H1 is given, delta Cp we calculated, T2, T1, everything is given. So if you calculate delta H2 would be, now delta H1 is already given, which is 24, right? 24. Now delta Cp is minus 0.024 and T2 is 250 plus 273, right? So 523. 523 minus and at 200 given, which is 473. Can you calculate? This would be the answer. After calculation, it would be the answer. So it would be like 250 into 24, it is 224 minus 50. 50 into this is 1.2. 1.2. So this will be 22.8, right? And since it is in calories, it will be calorie per gram. Got it, everyone? Everyone got this? Tell me, everyone. Yes? Okay. So question number 12 done. Pranjal? Now question number 13. How many of you have doubt in question number 13? Okay, let's solve question 13, everyone. So this is just a problem for the application of Hess law. Right, everyone? Okay, this is just application of Hess law. What you have to find? First, what you have to find? You have to see what is given, what you have to find. Given that, find enthalpy of formation of ICl. So write down the reaction of enthalpy of formation of ICl, which is this I2. Now this I2 in elementary form, I2 exists in solid form, okay, plus Cl2. So it will be half Cl2, right? Now this also will be half I2. Will give me ICl. Yes or no? Right? Tell me. So delta H formation you have to find. Now use your these reactions. Okay. So just write down all the reactions. Write down all the reactions. So this is reaction A. You have to find reaction A. You just have to use Hess law. So Cl2. Reaction is already written, so I need not to write this again, right? Reaction is already written now, so I need not to write this again. So tell me, what would be the final reaction? What would be the delta HF? This is reaction 1, 2, 3, 4. How should we add this? I2 solid half, right? I2 solid half into 4 plus half Cl2. So half into 1, then tell me. Plus, now if you see this, half solid, half gas, if you add this half gas and half gas will get cancelled. So it will be half of 3 also, because I don't need this I2 in product. Okay. Now this ICl, see this ICl, it is in reactant side, but we need that on product side. So it will be minus of 2. Got it, everyone? Tell me, got this? Yes or no? Yes or no? Okay. Okay, everyone. So just add this, you will get the answer. Okay, just add this, you will get the answer. Okay, everyone. Okay, I hope all of you got this. Right? This is basic application of Hess law. Next, 14 to 16. 14 to 16. Any doubt in 14 to 16? I guess if you understood question 13, you should be able to solve question 14. Yes or no? 14, 15, 16. So 14, no doubt, I guess. 15, also no doubt. Right, it's basic. Formula putting getting 16. Let's see question number 16. 14 is application of Hess law, right? So I guess all of you who have understood question number 13 should be able to understand question number 14. 15 is your basic delta U is equal to Q plus W, first theory of first law of thermodynamics. So 15 would also be easy. 16, if you see question number 16, right? So what is the reaction? Let's see question number 16 first. So reaction is given. What is the reaction? Tell me. Reaction is already given, right? You have to calculate the internal energy. So first you have to calculate delta H. If you have to find delta U, you have to find delta H first. Can you find delta H? Delta H is already given. Okay. So the enthalpy change at the constant pressure is. So we know that delta H is already given, right? Delta H is already given. This is delta H. Now, delta U is equal to delta H minus delta NGRT. Yes or no? Right? As simple as that. As simple as that. So delta H is given, delta U, NG you can calculate, R is given, T is given. What is doubt in this problem? What was the doubt in this problem? This was basic formula putting getting delta NG is equal to what? Now this is product mass reactant. So 1 minus half minus 3 by 2, which is equal to minus 1. Yes or no? Everyone? This is minus 1. R is given, T is given. Just put it, you will get the answer. Okay? Okay, everyone. So 13 solved. Okay. Now level 3. Level 3 we will discuss in advanced class only. Okay, so you can just leave level 3 for now. Now 6.4. We will discuss the homework of 6.4 first. So just take 2 minutes. Okay, everyone? Just take 2 minutes. Write down all your doubts, what you have, okay, at once. Then we'll decide, okay? Right, everyone? So, question number 4, we'll start for question number 4. Just see question number 4. Okay, 4, 8, 11, 12, 16. Now, question number 4. Which of the following method reaction of heat is not correct, right? Just see this. This is basic theory. Question number 4 is basic theory. If you see question number 4, what is option A? Heat of reaction is heat of formation product minus heat of formation reaction. That's true, right? It's true. Okay, it's true. Now, heat of reaction is bond energy of reactant minus bond energy of product. That's also true, right, everyone? This is also true. Now, heat of reaction is heat of combustion reactant minus heat of combustion product. That is also true. We have already studied now that heat of combustion is same as heat of that bond energy, right? According to Hess law. Okay. Now, this heat of reaction is heat of solution reactant minus heat of solution product. Now, obviously, if these three are true, this should be wrong. Okay. Now, when you talk about Hess law, right, it is not applicable for heat of solution. No? Sorry, it is Hess law is applicable, but heat of solution, when you talk about heat of solution, it won't be this. Even though you add all the reactions using Hess law, it won't be this. It would be product minus reactant only. Okay. Okay. Right, everyone? So question number, after question 4, 8. Question 8. So the question number 8 was, let's see question number 8. What was question number 8? The heat of addition of, okay. Got it, everyone? So question number 8. The heat of addition of ethene is X1 and that of benzene is X2. Calculate. Okay, you have to calculate resonance energy, right? So it's quite easy. Just write the reaction first. Heat of addition of ethene. What is ethene? Ethene was C2H4 gives C2H6. Two hydrogen is added, so it will be H2 plus. Okay. Delta X is X1. Delta H is X1. And for benzene, which is C6H6 plus. Now this is C6H6, so it is C6H14. So how many hydrogen is added? You have 4 H2. Now it won't be C6H12, it will be C6H12 only because ring would be there. Ring won't disappear. It will be 3H2. Okay? 3H2. So delta H is given as X2. Now, technically, we have one double bond here, three double bond here, right? So this X2 should be equal to 3X1. Yes or no? Tell me. Yes or no? Technically, X2 should be equal to 3X1. Now, that's why I told you the concept of resonance energy. In case of second reaction, we have resonance, and because of that, the energy will not be same, right? So this should be a theoretical energy, and this is your actual energy, right? So this is wrong. We cannot say this. So we know that resonance energy is equal to theoretical, which is 3X1 minus actual, which is X2. Got it, everyone? Tell me, everyone got this? Easy? Okay? Okay, everyone. This was fairly easy problem, conceptual one. So, question number 11. If you don't have, if you have any doubt, please ask. Okay, don't shy away from asking doubts. If you have doubt in every question, please ask every question. But you have to try it at least. See the problems, see the examples, right? Go through the lectures and try to solve. Because the problems of thermochemistry is very easy if you understand the concept. How many of you feeling that if you actually understand what is happening in the reaction, you just have to add and subtract, nothing else? How many of you literally feeling this? That if you actually understand what is the reaction, what type of reaction it is, you just have to add and subtract the values, that's it, right? It is not as conceptual as thermodynamics, okay? Now, when we talk about question number 11, just see question number 11, we have calculate the resonance energy. Again, this is problem based on resonance energy, okay? But, let's see, okay? Let's copy this. Okay. See, from next time, please message all the doubts at least 1 day before or even 1 hour before so that I could prepare this, right? It's taking time to see the problems and then relocate this, okay? So, bond energy is given. We have to find the resonance energy. So, we know that resonance energy is what? Theoretical minus actual, yes or no? Tell me, yes? Now, theoretically you have to calculate now. So N2O, the structure of N2 is this, N triple bond N, then O. Yes or no? Tell me, yes or no? Okay? Or, or, it is something like this, N, double bond N, double bond O, positive charge, right? Okay? So since we have, right, so we have these two resonating structures. There are two resonating structures, right, everyone? So let's see, what will be the heat of formation of this N2O? It would be N2 plus half O2 gives N2O, right? Okay, and we know that delta H of formation is equal to, right? Delta H of formation is equal to what? Delta H of formation of N2O minus product, sorry, reactant, which is 0. Right, everyone? Okay. Now, sorry, it is not 0 because it is N2, right? It is N triple one N. So we have to dissociate the bonds also. So let's see. So what is this delta HF of N2O? Tell me, what is this? We have triple bond, right? We have one triple bond here and one double bond here, right? Okay. Because N single bond O is not given, so we'll just take N double bond O, right? Okay, everyone? So we will have one triple bond, which is 946 actual one, okay? Plus, then half O2, one N double bond O, in this N2O, one N double bond O, which is half of, what is N double bond O? 600, 607. Okay, so you might be asking why I have taken 964. I should have taken 418, right? See, this is your bond energy. This is a bond energy, right? So delta H in case of bond energy is of product minus reactant minus product. So this is N2. This is N2. This is half O2, right? Sorry, half O2. 498. 498. Okay, right? Reactant minus react. It is bond energy. Now we are calculating bond energies. Delta H of reaction is bond energy of reactant minus bond energy product. So this is bond energy of reactant minus bond energy product, which is N double one N. This we will see this, right? N double one N, which is 418 plus N double one O, which is 607. Okay, everyone, tell me, right? This is a theoretical heat of formation, yes or no? Message me, everyone. This is delta H theoretical, right? This is theoretical. Experimental is given. Theoretical it is this. Calculated is this. So to calculate 946 plus half into 498 minus this, you should get something. Calculate 1877. Right? You should get something like this, right? 1195 minus 1025. Yes or no? Tell me. Yes. Right? So this is your delta H theoretical, which is your 170. Okay, 170. Now delta H experimental or actual is this theoretical is this. So we know that resonance energy is equal to what? Calculated minus actual. So 88. Okay, got it? Right, everyone? Okay, everyone? Okay? Okay, everyone. So this was done. Okay, so I hope 16.4 is also done. So again, level 3 we'll discuss in advance only. Those who wants to solve this 12 and 13, or those who want to see the discussion, you can attend this week's advanced out solving class. Okay. Then 6.5. 6.5 homework. Okay, 1 to 5. Have we discussed 6.5 for homework? I don't remember actually. Have we discussed 6.5 homework? My voice is breaking? No, right? It's not breaking. It should not break. Everyone, am I loud and clear? I should be loud and clear, right? Okay. Sneha, my voice is not breaking? Okay. So 1 to 5. 1 to 5. Anyone have any doubt? Tell me. Anyone have any doubt between 1 to 5? Okay, question number 2, question number 4. Then question number 2 and question number 4, both are very basic problems. Okay, right? You just have to go through the theory that we have studied. In this one, question number 2, H2O liquid is converting into H2O gas. Okay, right? Both temperature and pressure is same. If both temperature and pressure is same, right, liquid is getting converted into gas. So disorderness is increasing or decreasing? Just think about this. Disorderness is increasing or decreasing? It is converting from liquid to gas. Okay, it is converting from liquid to gas. So disorderness is increasing now, right? Increasing. Disorderness will increase because it is converting from liquid phase to gaseous phase. So delta S is 0. Got it? Delta S is positive. Delta S is positive. Okay. Now since it is at constant temperature and pressure, okay, constant temperature and pressure, so delta G should be 0 because it is in equilibrium. Okay, equilibrium delta G is 0 now. So the answer is A. Now when talk about question number 6, again, delta S of reaction is delta S of product minus delta S of reactant. Yes or no? Right? It is just same as your delta H. So question number 4, you can solve like that only. Okay? So 1 to 5, any other doubts? Any other doubts? Tell me. 1 to 5. No? No doubts? Okay. We will solve question number 6 to 11. Tell me, 6 to 11 or 6 to 12? Any doubts from 6 to 12? If you have solved, please ask. Okay, right? You should have solved. 6 to 11. No one have any doubt? None of you have any doubt. We have solved this 6.5 a week ago, more than a week ago. Mansi, Anjali, Pritam, I know that most of you haven't solved this. Okay. Kushi, Koshi, any doubts? Samya, no doubts? Meet, Siddharth, Tulip, Suhas, Soumya, Sanya. You guys haven't solved. Okay. And we have a test on this Sunday. I know what will happen. So I'll just discuss, okay, each and every problem. So 6, when you talk about 6, this is fairly easy problem. Okay, you have delta H given, delta H of fusion is given, temperature is also given. You are asked to find entropy change. Okay, so we know that entropy change delta S is equal to delta H. So entropy change is given, you have to find the temperature. Okay, temperature. So we know that delta H by T is equal to delta S. So delta H is given, delta S is given. Temperature, you can, okay, temperature you can find. So sixth one is easy. Now seventh one, basic formula. Delta S is equal to NCV, this is pressure, right? And the temperature is constant. Okay, temperature is constant because it is not given. So you have to consider, okay, it is given as 30 degrees centigrade, so temperature constant. So you just have to use the pressure term. So it will be NR ln P1 by P2. Okay, so seventh formula been getting. Eighth, when you talk about 8, it is also formula putting getting, right? Volume change is given. Okay, temperature is constant, volume change is given, so formula would be NR log ln V2 by V1. Okay, so 7th, 8th, same formula changes. You have to use formula. Now question number 9. 9 also same formula putting getting, right? Volume change is given. So this is also NR ln V2 by V1. 10th theory. Okay, 10th theory, you have to see the changes. So I guess 10th you could solve. 11th, tell me, 11th, we know that in 11th, right, we have solved one example which is same as question number 11. Okay, we have a system which is a mixture of hydrogen and oxygen, and we have solved question number 11, I guess. We had solved question number 11, right, everyone? In that case, it was only two gases, 1 mole each. So it was 1 by 2, 1 by 2. In this case, we have 1 mole of N2 and 1 mole of O2. So it would be 1 by 2 and 2 by 3. I guess all of you remember we have solved exactly same problem as question 11, but in that case, it was equal volume of N2 and O2. Okay. Now, question number 12, if you solve question number 12, evaluate the change in entropy of fusion of gas. Again, it is delta S is equal to delta H by T, right? Now, it is given that delta H of fusion is already given, which is, tell me, 6. Temperature is also given, which is 270, right? Got it, everyone? So, delta S, you can calculate Okay, so this is for 1 mole, right? Delta S will be for 1 mole. But in 90 gram of ice, we have 5 moles. So just multiply this by 5. Got it? Now question number 13. Again, 13 is formula putting getting, right? Now the only difference in 13 is instead of Cv or Cp, you have specific heat. So we know that heat capacity is equal to m into specific heat. Okay, m into specific heat. So mass is given, specific heat is given, right? Okay, so you can calculate delta S, right everyone? So in this case, delta S is equal to 2.303, 2.303, right? Now, instead of this heat capacity, we will write m into C. And again, same formula. Log, tell me, T2 by T1. Got it, everyone? Right? So question number 13, you can solve like that. Okay? Anyone have any doubt? Tell me. We have discussed, I've already discussed all the problems, even though you didn't ask. 6.5 was fairly easy. Okay. Now, level 3, only one question to be discussed in advanced problem solving. Okay. Any doubt? We have discussed 6.1 to 6.5 in class. Last question, okay, Sanya? See, last question, what is given? See, you could just use the formula delta S is equal to 2.303 because you have to use log. So whenever we use log, you use 2.303, right? Now, this is either Cp or Cv, right, depending on the condition. So just write as C and log T2 by T1. But this C is a heat capacity. Specific heat capacity is given. Heat capacity is mass into specific heat capacity, right? So this capital C's heat capacity is 4200 into 10, right? Into 10 minus 3 because it is 10 gram now. This is in kg. Okay, everyone? Right, everyone? Tell me. Got this? Okay. So we have lots of time left. Next class, Wednesday, we will complete TPP. Okay, we will complete TPP, and since we have time left, I'll just we will have one Kahoot quiz of this thermodynamics. We'll have Kahoot quiz of thermodynamics. Okay, so everyone, please ready, and the reports will be sent to your parents. So please be ready and be serious about the test. Okay. Try at least. Everyone, please be ready. The code is 752401. Everyone, please join 752401. Everyone needs to join. Even if you can't play, if your internet has some issues, at least join. Okay, because if you won't join, you will be marked as absent. If you don't have Kahoot app, you can join at kahoot.it on your web browser. Okay, 33 students have joined till now. Okay, I guess others are not joining. Just join Abhiram. Okay, just join and just see the problems. Okay, you don't have to. If you can answer, it's fine. Otherwise, just join and see the problems. Okay. Okay, let's start. So the first question is, in which of the following neutralization reaction the heat of neutralization will be highest? Okay, right? So the options are, see the options. It's fairly easy problem. I hope all of you can answer it correctly. It's fairly easy problem. I got only 14 answers till now. It shouldn't take that much time. It's a basic concept. Ten seconds left, everyone. Thirteen students were wrong. See, we have studied, right? Neutralization. Okay. For don't worry, Anisha, you can just join late. Okay. Just see the problems first. At the end of the class, at least you should join. Okay. So the answer is NaOH because strong gets in strong base. Okay. Next problem. So see the scoreboard. Oh, very good. Some people are in 900. So they clearly understood the concept. No, Viram, it's fine. Okay. Those who are unable to join, at least try and see the problems. Okay. The bond energies of HH, BR, right? HH, BR, and HBr are 433, 192, and 364, right? Then calculate delta H for this reaction. Everyone calculate. right? So it will be 433 plus 192 minus 2 into 364. Okay, let's see the second problem. See the scoreboard. Okay, there's a huge change. Everyone is replaced, I guess. Okay, next problem. So reaction is given. The absolute enthalpy of neutralization of the given reaction is.